Hi everyone, I'm Pranjay Shyam from KAIST and I'll be providing a brief summary of our paper exploring data efficient techniques for image restoration and enhancement. Image restoration and enhancement algorithms are needed to recover a degraded image so that the performance deterioration observed in high level perception tasks is minimized. To do so, state of the art approaches rely on supervised learning mechanism to train a CNN in the mapping between the input degradation image and output clean image. However, the number of paired samples needed to achieve peak performance remains unknown, and it's an extremely critical piece of information since constructing a paired dataset is time consuming. Furthermore, the training dataset should also be able to account for non homogeneous degradation distribution, wherein different regions of images are affected by different intensities of degradation. Towards this objective, we first design a region modification based augmentation pipeline that allows us to generate a large degradation space, which can be used to train a neural network uh, by images that have non homogeneous degradation distribution. So, this ensures that the restoration or enhancement algorithm is able to both localize and reconstruct the affected regions. We observe this approach to be extendable to training generative adversarial networks that usually have higher uh, training dataset requirement. Now, the benefit of using GANs is that the restored images have higher perceptual qualities. And so we observe that using a carefully crafted degradation space actually provides us with a large number of samples that can be used for training GANs without relying on a large input training dataset. So case in point is image deesnowing, where we have region modification based data augmentation techniques that result in a large augmentation space that can be used to train a CNN under different configurations. And we observed that training a neural network with a large augmentation space along with GANs result in images having higher perceptual quality. So we extend the visual evaluation of the degradation space for image deblurring tasks, image dehazing, low light image enhancement, and image deraining. So the key observations and takeaways from our paper is a properly implemented data augmentation pipeline can actually improve in image restoration performance, and it actually allows us to use a smaller data set to reach peak performance while using a reduced number of training epochs. Now, this approach can be extended to training GANs without explicitly requiring a large number of training samples in the original data set. But this actually comes with the increasing number of training epochs on account of training the discriminator subspace as well. So thank you for your interest and feel free to drop any questions at the provided GitHub repository.